Alright, so we're going to discuss some statistics again this week in research methods class. So let's go ahead and talk about Chapter 8. Our objective for this podcast is for me to provide you just an overview of correlational statistics. So let's jump into it. And so we have two important words. We have the word co and we have relations. And so what we're looking at is a relationship between two variables. Or we can look at a relationship between the dependent variable, which is called a criterion variable, and two or more independent variables, which are called predictor variables. This one's called a multiple regression, also known as a regression analysis. And what I'm going to do is explain the first one, which is a simple correlation, which is the relationship between two variables. Spend a lot of time on that, and we're going to spend most of our time discussing that. And we'll spend a very little bit of time on regression analysis or multiple regressions. Okay, so what a correlation is a relationship between two things. Just like in a marriage, you have a relationship between a man and a woman. We're looking at a relationship between variables. So another one is X related to Y? So for example, smoking X and cancer. There is a relationship. Is there a relationship? Yes, there is a relationship. Smoking and cancer are related to one another. Does smoking cause cancer? No, smoking does not cause cancer. If you smoke, you have a greater risk at having cancer. Does not necessarily mean you're going to get cancer. You can't say that smoking causes cancer, because people who have cancer or get cancer, not all may necessarily not smoke, and all those people who smoke may not necessarily get cancer too. Smoking doesn't cause cancer. If you do smoke, you have a greater risk of having cancer than somebody who does not smoke. There's a relationship between smoking and cancer, but it's not a cause. There's just some kind of relationship between the two variables, smoking and cancer. And how we measure or determine if there is a relationship between variables is a statistical term called correlation coefficient. A correlation coefficient is a numerical value for that relationship. So we use numbers to determine the relationship between the variables. And the range of that correlation coefficient ranges from a -1 all the way to the +1. So you can say it's plus or minus 1. The closer we are to number 1, the better that relationship. The further we are further away we are from 1, the weaker that relationship is. The statistical calculation we use is called a Pearson's product moment correlation, and from here on it's called Pearson's, and it is symbolized by the little r. And if you notice in this lecture that all the statistics are italicized, in APA the statistic abbreviation should be italicized. So we use a little r. Little r equals Pearson's product moment correlation. Again, that's a statistical test used to determine the relationship between two variables, X and Y. I'm not going to bog you down with actually the statistics of doing that, because our computer programs do all this stuff for us. So I want you to understand the concepts behind the numbers, not actually how to calculate the number. So Pearson's gives us a number, and there's a couple different things that it tells us and gives us association between scores. And this association can be seen by directions, and if you look at the charts on the right hand side, we have 4 different pictures that are telling us some pretty important things, because what we can do is we can actually plot the numbers. We can, on the bottom of the chart would be X, and on the left hand side going up and down would be variable Y. We can take the number for X and the number for Y, put a dot, and we can do that for all our numbers. And so what we can have is a relationship, or the correlation can be what's called positive or negative. So if we look at our picture here, on the picture on the top left hand side shows a picture of a positive relationship between two variables. As variable X increases, goes from low to high, and variable Y also increases, goes from low to high. That's a positive relationship. This is also known as a direct relationship. We'll go back to our smoking and cancer. Smoking would be X down at the bottom, cancer would be Y, variable Y. So as somebody smokes longer, we have a greater risk of causing cancer, or I don't know if catching cancer is the right word, getting cancer increases. That's a direct relationship between smoking and cancer. It's not a cause, and there's just a relationship there. Now the opposite side of that is what's called a negative relationship, and that is the picture on the top right hand side. So as X goes from low to high, Y starts going down. So if you look at that on the low side of X, your Y value is very high, and as we move towards the high X, Y is starting to go down. So that's a negative relationship. As X goes up, Y goes down. This is what's called, also known as not a direct relationship. There's not a direct relationship between the two variables. They're opposite relationship. As you can see there in the positive, the graph or the picture there is going towards the right hand side. This is the picture on the top left. And with a negative relationship, it's going towards the left hand side. Now if you look down at the bottom left hand side picture, you'll actually see that all the dots and everything look like a circle. That means there is no relationship there in these two variables. They're just scattered all over the place, and so there's no relationship there. Now let me tell you something. In the book we'll talk about that we're looking for a line. What we can do statistically is we can use a statistical procedure, or excuse me, you can use a Excel or SPSS software programs, and we can actually draw a line that fits here the best. Well, the one that has no relationship, there's no line there because they're just scattered all over the place, so there's no relationship between these two variables. Then down at the bottom right hand side, it looks like a V or a U. When we graph it all out, that's called a curvilinear relationship. So there's a midpoint there where there's no relationship, but to the left and to the right of that there's some relationship there. That gets a little bit beyond the content of this class, and we're not going to worry about that one too much. Again, the things we want to focus here is that a relationship can be positive or direct, or it can be negative, not direct, between the two. They can be related or not related is another way to look at it. The direct is related, or positive is related, negative is not related. Or they can have a negative relationship. Doesn't mean that's bad, it's just they have a negative relationship. Next thing we're going to talk about is the actual numbers and the degree of association of strength between those two relationships. Each of these numbers can be positive or negative. Doesn't really matter if they're positive or negative. Positive would mean it's a positive relationship. Negative would mean negative relationship. These numbers are used when we're looking at some research projects or research studies. They should provide these numbers. A lot of these numbers we're going to use in our Chapter is 3, if you're going to use some kind of instrument to measure your study, whatever you're doing, and we're asking about reliability and validity. Talked about that last week in, I think, Chapter 11, that you have to report the validity of the instrument, and there'll be an R number, and that's the number you have to report. So if the R number is 0 to 19, there's no relationship at all. There's nothing going on between those two variables. If it's 0.20 to 0.35, there's a slight relationship. There's something there, but not too much. 0.35 to 0.65, some relationships limited. It can be predicted for something. It's okay. 0.66, 0.85 is good, strong relationship here going. And if we're going to try to use something for prediction, they actually can use it. We can predict y based on x. And then 0.865 and above, this is a nice strong relationship. It's useful for predictability, and we use this for validity and reliability for different instruments that we may be using in our study.